Alright, Assalamualaikum and
Waalaikumsalam.
welcome back
You dah
to
beli baru ni?
welcome to
Ni.
Dynamics class. Sekejap mouse ni tak ni. Okay, so today's class kita akan continue work energy method. I know we have learned work energy method and impulse and momentum method. We're supposed to go into chapter topic 3 today, but today I want to try questions that have spring involved because we haven't tried questions that have a spring. Okay, so work of a spring force. So what is the work of a spring force? Okay. A work of a spring force is work from 1 to 2 equals to the integration of Fs ds integrate S1 S2, but the formula is negative Ks. Okay, negative Ks ds S1 S2. So if you need to use the formula for work of a spring, is integration of negative Ks. So work of a spring, the formula will be negative 1 over 2 Ks2 squared minus 1 over 2 Ks1 squared. So is the final minus the initial. As you can see, the final displacement here, okay, the final displacement there minus the initial displacement. Okay, the reason why there is a negative, this is a negative work. Why? Okay, the work in this case, the work is negative. As you can see, the symbol negative in front. Since why? Since the displacement Fs x in the opposite direction. X in the opposite direction. That's why the spring force is always negative. Okay, opposite sense of uh, opposite sense to opposite sense to ds. Okay, all right. So that's why there is a negative sign. Okay, so we have tried a lot of questions that have forces in different angles. We also have tried forces due to weight, forces due to tension of a string. Now we are going to try a question where we need to calculate the work when there is a spring. Okay, all right. So let's do this question together to understand. This is just a basic question. Okay, you can copy this question. The 10 kg block rests from rest rest not from rest on, okay, rest on, okay, a smooth incline. Okay, so in this case, soalan this question, the incline is a smooth surface, there is no friction. Yeah, now if the spring, okay, is originally stretched, Allah, ejaan, originally STREC stretched, okay, originally stretched 0.5 meters. Okay, now determine the total work done. The total work work done. Okay, dia nak total work done by all the force, by all the forces acting on the block. Okay, acting on the block when a horizontal, okay, when a horizontal force P equals to 400 Newton. Okay, pushes the block. Okay, pushes the block Okay, up the plane. Okay, up the plane. Okay, S equals to 2 meters. Okay, so now draw this diagram. Okay, so let me draw the diagram. So we have a surface like this. It has an angle of 30 degrees. Okay, and then we have a spring. Okay, so this is a spring, and this is the block. Okay, the block, 10 kilogram block. Okay, all right, in this case, okay, there's a spring and they also have a force P here. Okay, all right, and the distance, okay, between from here to here is 2 meters. Okay, the bubble pen there. All right, okay, all right, okay, and then this is the stiffness of the spring. K equals to 30 newtons per meter. And then what else? Okay, so now, so when we want to do this, number one, for work energy method, we have to draw the free body diagram. Okay, so let's draw the free body diagram. Okay, let's draw it here. Okay, let me draw it here. Okay, so of course we have a weight going down vertically. We have a normal force, and then there's no friction, but we have a spring force. So the spring force we call Fs spring, and then we also have a P force. Okay, so that will be the free body diagram. Let me draw the P force using a different color, make it more thicker. Okay, this is the P force, and you also have a spring force, Fs, and then you have a weight vertically down, and then you have a normal force. And okay, so these are all the forces involved. Okay, now since this is work, it means we have to consider forces in the displacement direction. We have to resolve it. Okay, let's resolve it. Okay, now so we need to resolve this one, and we need to resolve this one. Okay, the picture is not clear. Let me draw again here for all of you to see. Okay, okay, let me draw again better. Let me draw it better. Okay, so at the center here, you have a vertical weight going down. At the You have a normal force, and then you have a force of the spring, and then you also have force of P. Okay, now since our block is pushing upwards, it means the direction of the acceleration is that way. So you have y, you have x is pushing upwards. You need to make sure that all the forces is in the x direction, because we want to consider the work in the x direction. Okay, so let's resolve the forces in the x direction. So here we have this one, this red color. So this will be W sine theta. Okay, why? Because the theta is here and our theta is here. Okay, this is our theta. So this will be W cos theta. Okay. And also the force due to P you have to resolve. So you have horizontal force and vertical force here. But what is the angle? Which one is the angle? Okay, let's take a look. Okay, let's say this is our force W here, and then we have force here, and then we also have a force here. So if this is 30, so it means this is 30. Okay, so this angle is theta. So this one will be P cos theta, and this one will be P sine theta. So don't always assume the one in the horizontal is sine. It depends on where the theta is. So I know you memorize W sine theta, cos the sine theta will be in that direction, but when you have a load P pointing in that direction is different. Okay, so now what type of work we have? So here it asks to calculate the total work. So what type of work we have? We have uh, work due to the weight. Okay, We have work due to the force P. We also have work due to spring. So we want to calculate the work. Okay, now, so you know the formula for the work is the force multiplied by the displacement. So as you know, that it displaces 2 meter. Okay, from the diagram here, it displaces how many meter? 2 meter. Okay, so the weight is force due to weight. We need to consider forces in the x direction only, in this direction. So what we have? We have this one, W sine theta. We have W cos theta, and we also have work due to spring. Okay, now we have those three forces. So let's write down. So we have, okay, now work due to weight. Now it is going upwards, but the direction of the weight is going down. So you need to put a negative sign. So W sine theta multiplied by 2 meters. So it must be negative mg sine 30 times 2. Okay, please calculate that. What you get? Okay, so force due to weight, you should be getting the value to be, okay, negative 98.1 joule. Okay, okay, force due to P, because it's the same direction as the direction of the displacement where the block is pushing upwards, then it means that this will be P cos theta times 2. And here given P is 400 in the question. 400 times cos theta times 2. Okay, so you need to calculate that. 400 cos theta times 2. You should get the answer to be 692.8 joule. Okay, now for the force work done due to the spring, we know that the formula I've already mentioned to you is negative. Okay, let me put it here. Negative 1 over 2 ks2 squared minus 1 over 2 ks1 squared. Okay, now what is K? K is the stiffness of the spring. What is S? S is the displacement. But here you need to find the final displacement and the earlier displacement. Okay, if you look back at the question, it says the spring is originally already stretched at zero point 0.5. So that is S1. So we can say our we can say our S1 is 0.5 meters. And our S2 is what? It must be 2 plus zero point 0.5 because its final displacement is 2 meters. So in this case, S2 will be 2 plus zero point 0.5. So it becomes 2.5 meters. So if you put in the formula, 1.2 times 30 times 2.5 squared minus 1 over 2k is times 30 times S1 is 0.5 squared. Okay, calculate for me what you get the answer. So if I calculate it quickly, I would get it to be negative 90 joule. Okay, so that is the answer. So now that is the answer. Okay, so let's look at the answer. This is the first answer. This is the second one. And this is the third one. Okay, all right. So what do you get here? Okay, so you since they want the total work, so it must be you need to write it down the value that you get. So what you get? First you get negative 98.1, so negative 98.1, and then secondly you get plus 692 plus 692.8, and then the third one you get 90 joule. So 9 minus 90. So you need to total up this one. So when you have total up this one, if you use the calculator, you will get 505 joule. So this is the work that has been done by the spring, the block, due to the spring and all the other forces. Okay, so that is the answer. Okay, all right. So the important thing here is you know how to use the formula of U spring, which is 1 over 2 ks squared minus 1 over 2 ks squared. Okay, tapi you must remember you must have this negative sign. Okay, don't forget this negative sign. And don't forget, it must be final displacement minus initial displacement. Okay, final minus initial displacement. Okay, so as long you know how to use that formula, that is fine. So there can be questions that have a spring involved. So if there are questions that have a spring involved, you need to you know how to use this formula. Okay, all right. So done with that. So I think we can go to chapter. We can go to topic chapter 3. Okay, topic chapter 3. Because topic chapter 3 is in your exam. And what is it called? Kinematics of rigid body. Okay, now to understand this topic, chapter 3, which is kinematics of rigid body, you need to understand the motion. Now, when we're talking about topic rigid body, it now involves a topic rigid body now. Topic rigid body now involves forces. Okay, it involves no. What I mean forces. I mean topic rigid body now. It involves Allah. It involves what you call shape and size and rotation. Okay, rotation. So any question that has it gives you a diameter of the diameter, it means it includes the size. And if the question involves rotation, it's rigid body. So that's how you know it's topic rigid body. But now we're still in kinematics. Kinematics only involve the geometry aspect, which is the position, time, acceleration, and velocity. There is no forces involved. Okay, so we're going to repeat what we have learned in chapter 1, but in this time, we're not doing particles, we're doing rigid body. Okay, all right, so this topic is included in the test. So you need to understand how to do this question. Okay, okay, give me a second. Now, when you study this topic is actually important when you start designing a machine like gear. Okay, those are most common type of question. Gear. You know gear in this topic. Okay, so what we do is we're going to apply the equation of motion, and then we're going to relate with the forces of the body and the body's motion. That is what we're going to do today. Okay, all right. So before that, what we need to do is we need to understand there are different types of motion. Okay, now let's understand the different type of motion. Okay, so when you have a particle like this, and then it moves to here, okay, you can see that it's moving in a straight line. Okay, when it's moving in a straight line like this, okay, this is called a path of a rectilinear motion. Path of a rectilinear motion. Okay, so this is the path of a rectilinear motion. So because it's moving in a straight line. Okay, okay. Next is path of a curvilinear. Okay, so when you see like this particle is being dragged in a straight line. So this is called path of a rectilinear motion. Okay, now, if you see a particle like this and then it start moving in a it moves in a curved line like this, what do you think is called? If anyone can tell me. This is called path of a curvilinear motion. Okay, all right, this is called a path of curvilinear motion. Okay, so in dynamics, what you need to do is you need to understand how is the motion moving. Is the motion moving in a straight line? Then it's called a rectilinear motion. If the motion is moving in a curved line, then it's called curvilinear motion. But we also have in this topic where the motion is rotating about a fixed axis. So if the motion is rotating about a fixed axis, it looks like this. It rotates. So this is what we call rotation about a fixed axis. Okay, so there are actually four types. Okay, what you see here, this is type number one, this one is type number two, and this one is type number three. So you need to know all these types. But we also have for another type, because each different types have a different solution in solving. That's why it's important for you to understand the different type of motion, how it moves. We can also have a combination of translation and rotation. If a combination of translation and rotation, let's say this is our particle and then it rotates. So it's not only moving in a translation, it's also rotating. So you can say it's rotating and moving at the same time. So if it's a combination of translation and rotation, we have a name for it. Okay, the name for it is called general plane motion. Okay, all right. So by the end of this class, you need to identify the different types. First, you have path of a rectilinear motion. Second, you have path of a curvilinear motion. All right. Next, you have rotation about a fixed axis. Okay. Then finally, we have general plane motion. So it means for different types of motion it has a different types of solution. So the thing that you need to understand is what type of motion it moves for each type of question. If it's a general plane motion, there's a different type of solution. If it rotates, there's a different type of motion. If it only moves in the rectilinear motion, there's a different type of solution. Okay, as long as you know how the motion is, you understand. Like for example, the ceiling fan. Ceiling fan, it moves in rotation about a fixed axis, right? Ah, so that is one solution, one problem that you can identify. Okay, let me draw you this item, and I ask you what type of motion it moves. Okay, this is a car. Okay, so I'm asking you the wheel of the car. So what type of motion the wheel of the car is? Does anyone can tell me? Let's say it moves to another position here. What type of motion this wheel car? Everyone asleep? Are you online?
Rotation, madam.
Rotation only. It cannot be rotation only. If it rotates, it will just rotate here. Rotate here. It cannot be rotation only. You must have translation as well. Because if it's rotating about fixed axis, it will not move. It will only be in that position. But because it is moving, it is a combination of rotation and translation, because it's been translate from this position A to this position B, and at the same time it's rotation. So this is actually called general plane motion, because it's a combination of rotation and translation. Actually, the word translation, you can define it as being drag. You drag it from one point to another point. Does it change position? If it changes position, it means there is translation. If it doesn't change position and it only rotates, it's just rotation about a fixed axis. So for this case, the tire of the wheel is actually general plane motion, because it's a combination of rotation and translation. Okay, understand? Okay, that's what you need to understand. Okay, now let's try some different types of questions. that involve this topic. But before that, let's go through what formulas involved in this topic. Okay, now, first of all, can you please list down all the basic kinematic formula that you have learned earlier? Remember, V equals to ds over dt, acceleration equals to dv over dt. What is another one? A ds equals to v dv. Okay, this is the basic kinematic, and then we have the constant acceleration formula. V equals to v naught plus act. S equals to s naught plus v naught t plus 1 over 2 act squared. V squared equals to v naught squared plus 2ac s minus s naught. Okay, now this is the formula that we learned in kinematics. Now we're still going to use this formula in rigid body, but we have an additional formula. Okay, what is the additional formula? Okay, let me write in the next page first. Okay, the additional formula is this. Uh, um, Velocity now, which is previously was meter per second, now in rigid body we call it omega. Omega, the unit is in radian per second. And what is it called? This is called angular velocity. Okay. And then previously we learned about acceleration. The unit is meter per second squared. Now is going to call alpha, whereby the unit is now radian per second. And this is called angular acceleration. Okay. Right. And lastly, we have theta, sorry, not theta. And lastly, we have a position where the unit is in meters, but now in rigid body, we call it as theta, and the unit is radian. And this is called angular position. Okay, got it? Okay, so velocity is now omega, which is called angular velocity. Acceleration is alpha, which is now called angular acceleration. And displacement s is now called theta, which is now radian and which is called angular position. Okay, right. So when you go back to the formula here, okay, okay, if we write back the formula, so it will be omega equals to d theta over dt. Okay, and this formula it will be called alpha equals to d omega dt. Okay, and this one will be alpha d theta equals to omega d omega. Okay, I think you can understand the rest. So the rest will follow on, whereby this will be omega equals to omega naught plus alpha c t. And then we have theta equals to theta naught plus uh, omega naught t plus 1 over 2 alpha ct squared. And lastly, we have omega squared equals to omega naught squared plus 2 alpha c theta minus theta naught. Okay. Alright, please write down that formula. If you can do it yourself, is better. Okay, so this is the formula. Uh, so what formula is this called? The first one is the basic kinematic, and the second one is the constant acceleration. But now this one is now called, okay, this one is now called constant angular angular acceleration. Okay, all right, so we're gonna use back these formulas. Okay, so to me, it's not that you need to memorize. You only know already the basic and the constant angular formula, the constant acceleration. So you just replace you just replace, what you need to do is you just replace per V as omega, acceleration as alpha, alpha, and then if you have displacement as theta. Yeah, that is the keyword that you need to know, you need to replace. But then these are the formulas that we are going to use. Okay, all right. So okay, so these are not new formulas, is the same, but it's just using a different symbol. Okay, but in this topic, rigid body, we have three new formulas that I want to introduce to you today. Okay, these three formulas is going to be in the apa? It's not given in the exam. Okay, the first formula is V equals to R omega. So as you can see, the combination of velocity R and angular velocity. Okay, right. This one, the unit will be in meters per second, and then we have AT, which is called to alpha R. Okay, this is tangential acceleration. The unit is in meter per second squared. And then we have AN, which is omega squared R, where this one is normal acceleration and the unit is the same, meter per second squared. But to make your life easier and for you to remember, I always remember this formula as vroom. So when I remember vroom, I'll close my eyes, is V equals to R omega. This one, AT equals to R alpha, I always remember it as ATAR. Okay, ATAR. It makes me easier to remember. Okay, 8 ATAR. Because this is tangential acceleration and then this is alpha R, so I assume it as ATAR. And then the last one is ANWA. ANWA kuasa 2. Okay, because is AN equals to omega square R. So ANWA kuasa 2. Try closing your eyes, guys. Try to close your eyes and remember. Okay, what is the formula for velocity? Vroom. Vroom is R omega or R omega. What is the formula for ATAR? AT equals to alpha R. What is the formula for AN? ANWA. AN equals to omega square R. See? You can memorize this formula easily by remembering the keywords that I mentioned here. Betul ke tutup mata tadi?
Betul.
Betul. Okay. Good. Okay, so you dah hafal tiga formula baru ni. Vroom, Atar dengan Anwar. So these are the three new formulas in topic chapter 3 that you need to know. Okay, let's kind of do a question that has this topic, this for this chapter, so that you get to know how to use it. Okay, all right. So um, okay. Hmm. Okay, kita ambil apa 2 minutes sekejap, penat menulis. Okay, sekejap, ambil rest sekejap 2 minutes. Penat. Alright. Okay, saya bagilah soalan you salin. Saya malas nak salin. Okay. Okay, now draw this diagram for me. Okay, tell me when you have completed doing that. Dah?
Sikit lagi.
Okay. Best ke online? Kalau tadi I jumpa face to face. Okay? Alright, kita buat eh. Okay, now. A cord is wrapped around a wheel, which is initially at rest. Okay? If a force is applied to the cord and gives an acceleration A equals to part t meter per second squared, where t is in second, determine the function of time. So ni nak jawapan dalam function of time. Dia nak apa? The angular velocity of the wheel and the angular position of the line OP in radians. So first soalan A dia nak angular velocity, maksudnya dia nak omega berapa, and then dia nak angular position, dia nak theta berapa. Okay, tapi apa yang kita ada? Kita ada A equals to 4t meter per second square. So macam mana daripada A ni kita nak dapatkan omega dengan theta? Okay, you kena ingat formula Atar, Anwar dengan Vroom. Okay, kita ada Atar. Okay, now A yang dibagi ni, the cord gives an acceleration of A ni. Ini kan, ini sebenarnya cord ni cord C-O-R-D. Okay, cord ni, ini sebenarnya dia tak mention dia adalah AT atau AN, tapi dia sebenarnya adalah AT. Sebab acceleration of the cord mesti dekat sepanjang cord ni. So sepanjang cord ni sebab dia T kan, tangent to the path, so dia adalah sebenarnya AT. So kita can say that AT sebenarnya adalah 4T. AT sama dengan 4T. Apa formula AT? Formula AT sama dengan alpha atar. Ingat tak? Alpha atar. AT sama dengan alpha R. Dan kita tahu AT sama dengan 4T. So 4T sama dengan alpha R. R adalah apa? R adalah 0.2. So bermaksud alpha sama dengan 4T bahagi 0.2. 4T bahagi 0.2 berapa? 20T. So maksudnya kat sini sekejap, so kat sini alpha sama dengan 20T. Okay. So alpha sama dengan 20T, unit dia apa? Radian per second squared. Okay. So daripada alpha ni macam mana kita nak dapat omega? Okay. Kalau you ingat dulu saya pernah ajar daripada position, velocity ke acceleration. Kalau kita nak ke bawah kita different shade. Kalau kita nak ke atas kita integrate. Kan? So ini bermaksud kalau kita nak position theta, velocity omega, acceleration alpha, dia sama. Ini kita kena differentiate, ini kita kena integrate. Okay, so sekarang ni kita ada alpha. Alpha kita adalah apa tadi? Okay, alpha kita adalah 20T radian per second square. Kita nak ke omega, kita kena apa? Integrate ke differentiate? Boleh jawab?
Integrate.
Okay, kita kena integrate. Okay, bila kita nak integrate, kita kena decide. Kita kan ada formula, 3 formula ni. Omega sama dengan d theta over dt dengan alpha sama dengan d omega dt. So kita kena pakai formula kedua, iaitu alpha sama dengan d omega over dt. So sekarang ni kita nak integrate. So kita nak cari omega. So kita kena bawa omega belah kiri. So dia alpha dt. So kita akan integrate belah sini, integrate belah sini. Ini kita integrate terhadap apa? So ini kita integrate terhadap omega, so kosong ke omega. Ini integrate terhadap time, kosong ke t. So bila kita integrate terhadap omega jadi omega. So ni jadi 20t dt. Okay, so macam mana nak integrate 20t? 20t integrate dapat apa? Cepatlah. 10t square. Radian per second. So dalam soalan ni dia dah mention, dia kata nak dalam sebutan function of time. So itulah sebabnya untuk soalan ni kita tak solve guna constant angular acceleration formula. Kita pakai formula function of time. So you dapat dah omega sama dengan 10t squared. Okay. Alright, good. So itu baru omega. So sekarang ni kita nak apa? Lagi satu soalan dia minta apa? Position. So daripada omega ni kita kena differentiate lagi sekali untuk dapatkan theta. So kita nak pakai formula mana? Kita kena pakai formula yang pertama ni. Omega sama dengan d theta over dt. Okay. So kita kena pakai formula ni, omega sama dengan d theta over dt. Sebab soalan ni nak d theta, so kita kena bawa belah kanan. So dia akan jadi d theta equals to omega dt. So ni kita kena differentiate, ni kena differentiate, ni kosong ke theta, ini kosong ke t. So ni akan dapat theta, ni kosong ke t. Apa omega tadi? 10 apa? 10 t dt. So 10 t square tadi kalau kita differentiate kita dapat apa? 3.333 T apa? T cube. Unit dia dalam radian. So macam itulah. Okay, so ini satu jenis soalan. Okay, alright. So ini jenis soalan menggunakan basic kinematic equation. Okay, apa kata kita cuba one more question menggunakan constant acceleration formula pula. Okay, so ini macam benda yang sama yang kita lalui masa kita belajar topik kinematics. Ingat tak masa kita belajar topik kinematics awal-awal chapter 1 particles, kita kena guna formula basic kinematic and then kita akan guna formula constant apa? Acceleration. Okay. So benda yang sama. Okay, saya akan bagi you all satu lagi soalan untuk you all try. Tapi ini menggunakan constant acceleration. Okay. Kejap saya share. Sekejap. Okay. Alright. So, mari kita copy soalan tu. Okay. Sorry, silap. Okay. Soalan seterusnya. Okay, ini soalannya. Okay. Gambar dia. Ni gambar dia. Okay. Tolong copy ni kejap. Lepas tu kita bincang. Okay. Tolong copy soalan ni. Lepas tu kita bincang. Okay. Saya akan datang balik kejap lagi. Okay, tunggu kejap Okay. Copy dulu. Okay, I am back. Dah salin dah? Okay, I am back. Dah habis salin? Ha? Hello?
Tengah salin, Doktor.
Lamanya. Ah. Dah. Dah ke? I makan roti kan? Dah ke? Dah habis salin ke? Hello?
Dah.
Okey dah bagi habis kunyah roti ni dulu. Ya, minum air ya. Air eh. Okey. Dah pukul 12. If you have another class that is going on, you can leave, but I am recording this video. But if you don't have class, please stay and watch until the end. Okay, let's do this question together. Okay, a motor shown in the photo is used to turn a wheel. Okay, and attached to a blower contained within the housing. So kita ada motor dekat atas ni. Okay, ada, and then dia attached to a wheel. Okay, the details are shown. Okay, if the pulley A is connected to the motor, begins to rotate from rest with the constant angular acceleration of 2 radian per second squared, determine the magnitude of the velocity and acceleration at point P of the wheel after the pulley has turned 2 revolution. Okay, now soalan dia nak apa? Magnitude of velocity, so dia suruh kita cari V. And then dia suruh cari acceleration, magnitude of acceleration. Okay, do you remember apa formula V? V equals to vroom. V equals to R omega. Dan apa formula acceleration? Kita ada dua. Kita ada tangential acceleration, I always call it atar. And then kita ada normal acceleration, I always call it anwa. Okay, anwa, kuasa 2. Okay, that's why omega kuasa 2. So these are the things that we need to use to find the answer to the question. Okay, tapi if you notice, we have a motor. Okay, motor dekat A, and then we have a blower. Okay, dekat A tu motor. Okay, so motor dekat A ni, kita ada R dekat A. R dekat A berapa? 0.15. And then kita ada alpha A berapa? 2 radian per second square. Dan juga dia ada bagi tahu apa, the pulley has turned 2 revolutions. So 2 revolutions. 2 revolutions berapa radian? Okay, so ni adalah maklumat yang kita dah ada. Ini dekat mana? Ini dekat atas ni, maklumat atas ni. Maklumat dekat bawah ni pula, dekat apa dia? Blower kat bawah ni, dekat point B ni, kita ada RB. RB kita ada apa? RB kita ada 0.4 meter, okay, jangan lupa unit. Dan kita tak ada alpha B. Kita tak tahu. Okay, so macam mana kita nak solve problem ni? Okay, ada satu clue yang you kena tahu. Sebab motor atas ni attached to blower kat bawah ni, velocity dekat atas ni sama dengan velocity dekat bawah ni. Ini satu key things that you kena tahu. Maksudnya velocity adalah velocity, apa formula velocity tadi? Vroom kan? Sorry, alpha pula. So maksudnya formula RA omega A sama dengan RB omega B. Okey, itu satu clue yang kita tahu. Sama juga dengan atar. AT R A alpha A sama dengan RB alpha B. Okay, ni satu benda yang you kena tahu. Because they connect together. Okay, the velocity up here is the same with the velocity down here. Okay, alright. And also the tangential acceleration. Okay, now soalan ni sebenarnya you kena baca betul-betul. Dia minta dekat point apa? Dia minta dekat point P. Okay, dia minta dekat point P. So bila dia minta dekat point P, maksudnya point P ada berada di mana? Dekat blower B. So you kena cari, sebenarnya yang you kena cari apa? You kena cari omega B lah. Dan you kena cari alpha B lah untuk jawab soalan ni. Itu maksudnya. Okay. Alright. Faham tak? Okay. So sekarang ni maklumat yang kita ada dekat A. So macam mana kita nak selesaikan ni? Okay, nombor satu, sebelum apa-apa, apa kata kita cuba selesaikan yang dua revolutions tu dahulu. Okay, dua revolutions. Okay. Satu revolution sama dengan dua pi. Kalau dua revolutions berapa? 4 pi lah. Okay, so itu adalah satu benda yang you kena solve dulu. Buat macam ni pun dapat markah satu markah kalau you boleh solve. Okay, sebab kita nak jawapan dalam radian. Okay, you kena ingat pertukaran unit ni semua. Okay, jangan masa exam lagi 2-3 minit baru nak masuk, baru nak ingat balik. So, satu revolution sama dengan 2 pi. Dua revolution sama dengan 4 pi. Okay, so 4 pi sama dengan berapa nilai dia dalam radian? 4 kali pi 12.57. Okay, so tu tak dapat. So tu dah dapat. Okay, now, so kita kembali kepada, saya tukar slide Okay, so sekarang ni kita punya ultimate goal ialah kita nak dekat point P, kita nak velocity kat point P. So untuk velocity kat point P, kita perlu cari RB kali omega B. Okay, so kita kena cari omega B tapi tak tahu berapa. So ni unknown. Okay, and then the next thing yang kita perlu cari ialah acceleration at P tapi tangential, itu atar. Okay, so kita tak tahu nilai tu And then kita juga perlu cari acceleration dekat P untuk normal. And ni Anwar P kuasa 2 R P. Okay, so ni benda yang kita cari. Sebab dia nak magnitude, you kena cari A. Magnitude maksudnya adalah AT squared campur AN squared. So ni adalah kita punya ultimate goal. Tapi kita tak ada nilai omega B ni, alpha B ni. So macam mana kita nak cari? Okay, first kalau kita dah tahu tadi kan saya ada mention velocity sama dengan RB omega B sama dengan RA dengan omega A. Okay, RB sama dengan berapa? 0.4. Omega B tak tahu. RA sama dengan berapa tadi? 0.15 omega A. So maksudnya macam mana kita nak selesaikan dapatkan V ni? Kita perlu cari omega A. So macam mana kita nak cari omega A? Kita kena tengok apa maklumat dalam omega A yang kita ada ni. So kita ada maklumat ni. So daripada maklumat ni macam mana kita nak selesaikan? Okay. So tadi kita ada RA, dia dah bagi berapa? RA 0.15. Alpha A, saya ulang balik kat sini. Alpha A dia bagi 2 radian per second squared. And then dia also bagi theta. Theta sama dengan 12, berapa kira tadi? 12.57 radian. Okay. So kita ada maklumat ni dan kita juga tahu dia start from rest. Kalau dia start from rest, kita tahu omega naught sama dengan kosong dan theta naught pun sama dengan kosong. So daripada maklumat ni kita kena cari omega A. Okay, macam mana kita nak cari omega A? Kita boleh guna formula constant acceleration. Okay, cuba tengok balik formula constant acceleration yang you dah produce tadi. Okay, formula mana yang paling sesuai dengan semua maklumat yang ada tu? Yang pertama, yang kedua atau yang ketiga? Yang mana? Jawapannya yang ketiga. Sebab yang pertama dan kedua ada time. Kita tak ada time. So kita kena guna formula yang ketiga. Tak sempat bagi you all jawab kan? Cepat je jawab kan? Okay. So kita guna formula yang ketiga. So formula ketiga adalah omega A square equals to omega naught square plus 2 alpha A S pula dah. Theta minus theta naught. Okay, so omega naught ialah kosong sebab ni kosong. Campur 2 alpha A adalah 2. Theta adalah 12.57 tolak kosong. Dekat sini kita boleh dapat omega A. So tolong dapatkan omega A. Dapat apa? Namanya kira? 7 point
50.28.
tak lah, 7.09 kan? Kuasa 2 ni dah puncakan belum? Sini saya kira 12.57
7.09.
kali 2 punca kuasa kelas. So 7.09 radian per second. Okay, so ni betul jawapannya. So bila kita dapat WA, kita boleh dapatkan WB. So tolong cari WB berapa? So berapa WB? So kita masukkan dalam formula tu. So 0.15 kali tu kali answer tadi bagi dengan 0.4. So kita dapat WB sama dengan sama tak? 2.659 radian per second. Dapat sama tak? So you boleh masukkan dalam formula ni untuk dapatkan velocity dekat point P. Sebab dia dekat blower B kan. So kalau kita masukkan dalam formula tu, okay, sekejap dia punya ni update. So VP sama dengan RB omega B. So RB sama dengan 0.4. Omega B dapat apa tadi? 2.659. So kita kali ni dengan 0.4, kita dapat jawapan 1.06. So ni adalah jawapannya 1.06 meter per second. So betul. Okay, tu dah dapat. Ni sekarang ni kita perlukan acceleration pula. So acceleration ialah acceleration pula AP untuk tangential sama dengan atar. So kita perlu alpha B dengan RB. Okay, kita ada alpha B tak? Kita tak ada alpha B lagi kan? Kita tak ada alpha B lagi. So kita boleh guna cara yang sama tadi. Kan tangential acceleration sama dengan RA. Okay, RA alpha A equals to RB alpha B. Okay, RA sama dengan 0.15. RA kita dah dapat 2. RB sama dengan 0.4. Alpha B sama dengan unknown. So kita boleh dapat alpha B. So alpha B dapat berapa kat sini? Okay, kita kira sama 0.5, 0.15 kali 2 bagi 0.4, 0.75. 0.75 radian per second square. Alpha B. Okay. Betul tak? Sama kan? Okay. So kat sini alpha B sama dengan 0.75 kali 0.4. Okay. So kali dengan 0.4 kita dapat 0.3. So itulah jawapan dia 0.3, tapi jawapan dia dalam unit apa? Bukan radian sebab ni acceleration Jawapan dia dalam meter per second square. Dan kita boleh juga buat acceleration untuk normal pula. Normal pula formula dia adalah ANWR, omega square R. So kita perlukan omega B tadi 2.659 kuasa 2 kali RB 0.4. So kita boleh terus dapat jawapan 2.659 kuasa 2, jangan lupa, kali dengan 0.4 dapat 2.828 okay, meter per second square. Last kali, so ni betul, ni betul, ni betul. So our last thing that we can do is we can calculate acceleration. So acceleration sama dengan AT squared campur AN squared. So berapa AT kita tadi? AT kita tadi adalah 0.3 dan AN tadi kita adalah 2.828. 2.828 kuasa 2. So ni kita boleh dapat magnitude lah. Ni kuasa 2 campur 0.3 kuasa 2. Answer dapat 2.84. So jawapan 2.84 meter per second square. So inilah jawapan dia. Okay. Alright. So that's for today's class. So I'm gonna give I've given you some homework. So if you look at your WhatsApp, after this, ni adalah soalan final last sem. So you all boleh cuba soalan ni. Ni soalan, bukan soalan final, soalan test sem lepas. Okay, cuba buat soalan ni dan kita boleh bincang dalam next class. Dan cuba soalan ni. Okay, sebenarnya ada 3 soalan. Saya terlupa scan soalan ketiga. Nanti saya scan soalan ketiga. So ni soalan chapter 1, motion of projectile. Okay, make sure you all cuba soalan ni. Dan ni soalan kinetics of particles. So ni topik chapter 2. Kalau you perasan dia guna Newton second law dengan work energy method. Dalam kat sini tak ada impulse. Okay, so dia boleh choose either one Dan sebenarnya ada soalan chapter 3 iaitu rigid body. I belum share lagi, nanti I share. So it's very good if you try these 3 questions for your practice for your final exam, dan you akan rasa bersyukur kalau you buat. Okay, so itu saja for today's class. Any questions? Saya akan share link dengan slide.